Assalamu alaikum. I am Dr. Hussain from Group 1 ID 1906034. Our project was IoT based remote power monitoring and control shutdown of PC. So, the problems we have to solve by this project are: 1. The power infrastructure for the device, IoT device; 2nd, energy efficiency; 3rd, remote monitoring; and 4th, remote control of the PC even by making it user friendly. The features our end product has are: 1. The PC can be turned on or off via an app connected to the ESP32 module through internet. Secondly, PC power supply mode can be monitored and alternated whether it is taking power from main supply or UPS. Thirdly, power consumption measurement. Fourthly, WhatsApp alert when overcurrent flows, and the threshold can be set by their respective user using the app. And fifth, automatic control shutdown after threshold current. Extra features: any device that is connected to the AC lines via our device can be remotely turned on, off, and monitored as well, not only just PC. The cost analysis: the components we used are ESP32 microcontroller, 5-volt relay, current sensor, voltage sensor, LDR, BJT, breadboard, and resistor. The prices are given on the left hand side table. The working principle: relay modules for on-off controlling, sensors to calculate power, LDR for power supply mode detection, and Android user interface for IoT. In the circuit diagram, we can see the AC input is connected to the current sensor and AC output is taken from the voltage sensor. This is where we actually connect the power cord of CPU, and this AC input is basically the main supply line at our households. Everything including the 5-volt on-off relay is connected to the ESP32, which is taking all the decisions based on the codes that we have written. Thank you.
Hello everyone, I am Shoshoban Dash. I am ID 1906053. Here is the code for our Blink interface. We have got a template name and authentication token from the Blink console. We have defined them in our code. We have also defined the voltage sensor pin and current sensor pin through which we can get the measurement of voltage and current. We have also included libraries to connect our device with the Wi-Fi. We have also added two phone numbers to get AC nominal and inverter status through WhatsApp messages. Here we have added Wi-Fi name and set the password. We have also set a current limit here. Here we have written this snippet so that the Blink interface will show us the voltage RMS value and current RMS value. We have also written a formula to calculate the power, and the power will be displayed in our Blink interface. Thank you everyone.
Assalamualaikum, I am Shahadul Hussain, ID 1906047. This is the code snippet to measure RMS voltage. At first, we configured the sensors, AC sensor, voltage sensor, current sensors, pin setup as input. We wrote a function to measure RMS voltage. Same function is written for RMS current as well. Since 50 Hz AC current have time period of 20 milliseconds, we took 10 cycles of it and measure the maximum and minimum values of each cycle and average them, then found RMS values, and then we did the calibration by a factor. This is the hardware setup picture in variable is shown. It contains voltage sensor, current sensor, relay, and ESP32. Complexity analysis: if we make our connections inside the CPU to detect and control, thus it should be more accurate, but to be user friendly, we do not do this in our project. Second, the BJT in the relay module was creating a great problem, which is solved by replacing manual BJT resistor to make the circuit module, since SMD mounted BJT module cannot be replaced in Bangladesh. Third is IoT client server selection. Blink profile have so many advantages, but it doesn't include more than 6 variables in the free version we are using. That's why we have to use WhatsApp for the 6 variable. Fourth, sensor calibration. AC voltage and AC current sensor calibration is tough enough to solve. When the power line is off, the device shows some noise power, since sensors are less accurate because it is so low cost. This is the blink console of our phone's app. The voltage, current and RMS voltage, current and power in watt can be noticed, and by changing the slide switch we can control the current limit value. It is actually scaled by 5, means that when you press 0.4 ampere in the current limit, it is actually 0.4 into 5, 2 ampere. So when 2 ampere or more current flows, the device will automatically cut the power line and also sends a message that's how much cover current flows to your device. Thus the on-off switch can control power on or off. Calibration. AC current, AC voltage sensor calibration is tough enough to solve by adjusting the port on sensors. We found these graphs on Arduino serial monitor plot. We found the calibration factor by measuring actual value, current value and voltage value through multimeter and the shown value in serial monitor plot. Limitation of our project. Since sensors are of low quality, a maximum rated power about 2500 watt can be handled, otherwise the device will be at risk, and this is not to be calculated. LDR holding structure should be very close to the light of UPS, since LDR has low sensitivity. Different UPS have different spacing between the lights, so it needs to be specific for LDR holding instruction. So different LDR holding instruction need for different UPS indication. Noise power of sensor, we have already discussed about when the power line is off, due to the accuracy of sensor, some power has been shown. That's all from me. Next, my group mate will continue.
Assalamu alaikum everyone. I am Fahadul Islam. My ID is 54. In this slide I am going to show the user manual of the device we have implemented. First, connect the AC supply line to the AC input of our device. Then connect the CPU supply line, or the device we are going to power. That's supply line should be connected to the AC output of our device. Then set the current limit value in BiLink app. The value is scaled by 5, so you need to set the values divided by 5. And for switching on or off, the push button push the slide switch in the BiLink app. In this slide, I am going to show the individual contribution of each member of our project. First, the circuit diagram was developed by ID 47. Then components were collected by ID 53 and 54. Arduino code for measuring power and relay circuit was written and debugged by ID 34. Arduino code for BiLink console was written by ID 53. BiLink interface was developed by ID 47. Soldering the components in the Vero board was done by ID 54. Calibration of sensors were done by ID 34, and the overall device was tested several times by all of the members. Mode of teamwork and diversity. First, we have planned the project, and based on our skill diversity and cognitive diversity, we have divided our roles and responsibilities, and the problems we have faced during the project implementation. We have solved these problems in a collective work, and finally we have completed this project as a teamwork. Evaluation of sustainability, environmental impact in our project, as we are not using such materials which has a bad impact or non-biodegradable materials. So it is environmental friendly, and the project is mainly aimed to improve the energy efficiency. So it is very much it will increase the resource efficiency, and the life cycle of our device will depend on the things or materials we are using to implement the project. And economically viable, this is aiming to improve the resource efficiency, so it is economically viable, and the cost of our prototype is not so much, so it is economically viable and social acceptance. As the implementer of the project, we think that this will be socially accepted, as the world is going to going to reduce the carbon emission and low power devices, and we think this is a scalable and replicable device in the industry in a long term, and in a long term our prototype device will impact in the to increase the energy efficiency and to the environment greatly. Thank you everyone. Assalamu alaikum.